For example, what was the problem we did on Monday? The problem we did on Monday was this one. QD equals 100 minus P, and QS equals minus 20 plus P. This was the problem that we did on Monday. Notice in this case I didn't use parameters. But we can see right away, using our current model, using our current terminology here, what is A in this particular case? A is what? 100. Yes, the vertical intercept. What is B? Be careful. B is not -1, but 1. Because this is written as A minus BP. So B is actually 1. That means the slope here is minus 1. But B is actually 1. C is equal to what? 20. Because the intercept is minus C, so C must be 20. Not minus 20, C is 20. And D is what? 1. D is just coefficient of P in that supply. So plug in to this formula right here, what do you get? P star then is equal to 100 plus 20 over 1 plus 1. 120 over 2 is 60. And that's the same answer we got yesterday. There is an advantage of these general solutions, particularly in the business situations where you're resolving a problem again and again with different parameter values. It's quicker to get the solution this way. Just get the general solution, express in terms of the parameters, and then just plug into this one. Okay, so this is the expression for the equilibrium price. We also want to get an expression for the equilibrium quantity. We also want to get Q star. There are two different ways of getting Q star. We could substitute into the domain curve or the supply curve. Let me just arbitrarily choose the domain curve. But as an exercise, you could show that you'll get the same answer if you substitute it in the supply curve. If we substitute it in the domain curve, then Q star is A minus B times P star. Now the reason this worked is if you're at the equilibrium price, then that's going to give you the equilibrium quantity, whether you substitute into either domain or supply. So you know if you substitute in the equilibrium price, that's going to give you Q star. Now we know what P star is in terms of parameters, because we just solved for it. So all you have to do is substitute in for P star. You get Q star equals A minus B times, let's put brackets here, A plus C over B plus B. And notice we could stop right here because what we have on the right-hand side of this equation, all parameters. So this is our solution. However, if you look up the answer in Chang, this is not what Chang has. And the reason is because Chang always simplifies the answers as much as possible. And it's possible to simplify this expression to get an equivalent expression that's just a little bit simpler. And here is how Chang does it. Notice these two terms, A and this term right here, they have different denominators. But if you can make these two terms have the same denominator. All you have to do is take this term A. By the way, A is the same thing as A over 1. A over 1 and A are the same. Now take this term, multiply the numerator and the denominator by B plus D. B plus D is your denominator over here. So if you want to get the denominators the same, you do that. Now that seems like it's making things more complicated, and at first it is, but we'll see that actually in the end it makes things a little bit simpler. So we could rewrite this as Q star equals A times B plus D over B plus D. And just let me put parentheses in there for minus, now we can bring this B, that's multiplied times this, so we can simplify the second term to be minus B times A plus C over B plus D. Now these two terms have the same denominator, and when they have the same denominator, you can just add or subtract the numerators. Like if you have 1/3 plus 2/3. 1/3 and 2/3 have the same denominator. So 1/3 plus 2/3 is 3/3. Same idea. So now we can rewrite this as A times B plus D minus B times A plus C over B plus D. Furthermore, if you multiply these two terms out, you get an AB here, and you get a minus AB here. So if you simplify that numerator, what you get is AB minus BC over B plus D. And actually, this is the answer that changes. It's a little bit simpler than this answer right here. And I like to go through this because it illustrates this idea of making two separate terms have the same denominator so you can add or subtract. Now let's check this answer out. When we went through the problem yesterday, we had this problem. Which we solved directly. And you recall when we solved this directly, what we got for our solution on Monday is P star equals 60, Q star equals 40. Let's check to make sure this formula works for this case. We just substitute in, or in this particular case right here, we get 100 times 1, B is 1, minus 1, B was 1, times C, and C was 20, over B plus D, 1 plus 1. So we get 100 minus 20 is 80 over 2 is 40. It's the same answer. Only now our answer right here is expressed in a more general format. Simple supply and demand.